Well, hello and welcome to this workshop hosted by the three Horizon projects, COSMOS, VIVALDI and CATCO2NVERS. I see we have 20 participants, 22 now, and lots more joining. So in the interest, all right, we're already up to 33. In the interest of timekeeping, I'm going to jump straight into it. So a very warm welcome to everybody that has joined us this morning. The aim of the workshop is to present EU policymakers and regulators the challenges and barriers perceived across the three projects, and to discuss possible solutions. In particular, the workshop will look at what incentives are needed to promote the uptake of alternative carbon feedstock in essential products. The workshop will look at the different carbon capture utilization pathways available to defossilize the production of chemicals, at ongoing discussions at EU level relevant to this space, and on recommendations on how to turn around the use of fossil fuel resources for the production of chemical and products in general. The webinar will be recorded, and the transcript will then be shaped into an article and shared to policymakers and stakeholders. It will be made available to us. Good. So a quick look at the three projects that brought us here today. I'd like to introduce you to that before introducing then the organizational team. So firstly, we have the COSMOS projects, which is developing solutions to transform carbon emissions from bioprocesses into sustainable bioproducts, such as durable polymers, renewable biochemicals, and biodegradable materials, enabling the production of greener packaging, coatings, and textiles. Next, there is the CATCO2NVERS projects, which, in an effort to reduce greenhouse gas emissions produced in bio-based processes, is developing innovative integrated technologies based on three catalytic processes, with the goal of transforming waste CO2 into 5 added value chemicals catering to the chemical, cosmetic, and plastic industries. Finally, focusing on 4 key bio-industry sectors, namely pulp and paper, food and drink, bioethanol, and biochemicals, the Vivaldi project transforms real off-gases into 4 high-value organic acids for re-entry into the plant's production process to enhance their sustainability and opening new business opportunities as building blocks for novel biomaterials. Sorry, just battle to find the Good. So let me quickly introduce the organization team that made this webinar and workshop possible. I will start with the CO2 Value Europe team. CO2 Value Europe is an international NPO association representing the European carbon capture and utilization community. CO2 Value Europe brings together over 90 pioneering members and covers the entire value chain with a vast network of organizations and individuals who together share the belief that carbon capture utilization technologies are necessary to help the EU reach its climate targets. CO2 Value Europe is proud to lead the policy and the communication dissemination activities within both the COSMOS and Vivaldi projects, and are represented here today by Anastasios Perimenis, Tude Bernier, and Lara Totolo. Between them, the General Secretary General, Policy Director, and Manager of Communication and Events. The second part of the organization team is Alchemia Nova, of which I'm the Managing Director, which is tasked within the CATCO2NVERS project, amongst other activities, to do a detailed analysis of the EU regulations, to identify possible barriers and enablers to the implementation of CCU technologies, and to identify the most promising conversion technologies. Based in Vienna, Austria, our mission is to create a world where all resources are truly valued and preserved, contributing to circularity and regeneration. To this end, we have navigated over 20 years of pioneering research and innovation development in the field of nature-based solutions, sustainability, and circular economy. And along the way, we've gained experience in bioengineering, nutrient resource capture, wastewater treatment, and biogenic substitutes for fossil-based products. I'm joined here today by Robert Slade from our project development team, and the de facto CATCO2NVERS project manager, namely Idris Cesare. Good. So let's quickly take a look at getting to the substance of the workshop. We're here to discuss and gain insight into the 3 following challenges. The first challenge is harnessing the benefit of alternative carbon feedstock, such as captured biogenic carbon, for the production of plastics and chemicals by creating binding targets for non-fossil carbon content and contributing to the recycling obligations. Challenge number 2 is the streamlining of the regulatory approval requirements for bioconversion processes in the valorization of captured biogenic carbon through the reduction of administrative red tape, in other words, registration costs, approval times, third-party involvement, and the harmonization of national regulations. The third challenge to be addressed today is securing a significant market share for captured biogenic carbon chemicals and products by establishing effective market pull mechanisms while evaluating the complexity of standardization and labeling of final CCU products and ensuring that product properties respect the downstream regulations. A quick look at the agenda shows how we intend to tackle these challenges. So as we can see, after my address, I will invite each project coordinator from the projects to briefly introduce their project for the sake of context. And the project coordinator will then invite the industry partners to present the challenges pragmatically and in their own words against the backdrop of the industry and field of expertise. This process will take us until 11:15, after which we will pass the word to Algriete Dumais from the European Commission for his talk on the transition pathways, before opening the floor to a question and answer session that will be hosted by Trudy Bernier. The Q&A is expected to last until about 10 to 12, when we will then cross to Anastasios for a summary of the key learnings. Please note that all audience members are free to post questions for the Q&A session. So please feel free to jot down your questions down in the Q&A function that you will find at the bottom of your control ribbon. It is next to the participant list. There's 2 bubbles that allow you to Q&A. Try to avoid the chat on the right-hand side or just a pure chat function, as the Q&A functionality allows us to like previously asked questions and therefore bring in the liked questions to the top. And it will then be easier to prioritize those questions that have got the most likes. So please use the 2 bubbles, the Q&A bubbles at the bottom there on the ribbon. Good. Let's move to the next slide then. So I think I've done good on time. I will be very strict with time and I will be interrupting speakers. Unfortunately, I will have to do that if we see that we're extending the time too long. And so without further ado, I'd like to introduce Nicolas Martin. He's the CO2SMOS project coordinator and scientific researcher at CATCO2NVERS, before passing the word to Gert-Jan Gruter, the CTO from Avantium.
Thank you, Francesco, for the introduction and all the organization for giving me the opportunity, the chance to introduce today CO2SMOS in this interesting workshop. So I don't think Lara. Okay.
You should have the control, yeah.
Now, yes.
Okay.
So I will give just a brief introduction of CO2SMOS, of what is CO2SMOS project. So it is entitled like biogenic carbon dioxide emissions and innovative chemicals for bio-based industries. So just the title is so revealing, so clarifying of what we do in CO2SMOS. As you can guess, our challenge is related with carbon dioxide released by different green sources in Europe from bio-based industries. And the solution that CO2SMOS suggests is to try to turn this carbon dioxide into bio-based products by using novel and cost-competitive conversion technologies. So having in mind these 2 main ideas about the challenge and the solution, we can absolutely claim that the ultimate goal of CO2SMOS is to enhance the circularity of these industries, these bio-based industries. So we will be able to reach this goal first by developing breakthrough technologies efficient technologies that are really able to turn carbon dioxide into high added value chemicals. And once we are able to meet this first goal, we will be able to work on processes with neutral or even negative greenhouse gas emissions. So neutral or even negative carbon footprint. And when we have these two first steps, we will be able to create new business models based on carbon dioxide, on the utilization of carbon dioxide. So just take a look on the technologies and the products on the technology core of Cosmos. How do we do this? How do we convert carbon dioxide into products, into bioproducts? So we have a few lines, a few processes, and we can say that all of them have like probably 3 stages. The first stage is the conversion of the carbon dioxide into bulk chemicals, into syngas and bioacetate, that are not only valuable for Cosmos, but as all you know, are really, really interesting bulk chemicals. So then we have a secondary conversion of these bulk chemicals and carbon dioxide as well in other value chemicals. We have 7 chemicals, intermediate chemicals in Cosmos, PHA, PHB, 2,3-butylenediol, VTEX, etc. And the last stage is to integrate these intermediates into bioproducts, more specifically in the production of plastics. So regarding the technology core, the technologies that we develop, we can say that we have like a 2-legged project. We have some processes based on biotechnology. So we have, for example, gas and liquid fermentation inside this first leg of the project. And then we have other processes, let's say chemical processes, and more specifically catalytic processes. We have catalysis, we have biocatalysis, we have co-electrocatalysis. So they are not separate legs. And sometimes they have some synergies between them. So these routes are a bit complex and a bit challenging, but well, it's what we are facing, what we are trying in Cosmos. And all of these technologies are supported by renewable sources such as green hydrogen and biomass. Well, Cosmos is a research and innovation action, so we started trying and checking our technologies at the labs, working at lab scale to optimize everything. And after that, going a step forward towards the upscaling and validation at pilot plant scale. So we can say that this slide is a nice snapshot of the project, where we have the products, the technologies, TRLs, etc. But anyway, if you have any question, any doubt, you can find more information in our website. So finally, regarding the consortium, the Cosmos team, the project is coordinated by CARTIF. We are a technology center here in Spain, and we have 15 partners from 7 different countries. So we have as well other technology developers, other research institutions, service providers, knowledge hubs such as carbon dioxide value. And finally, we have 3 companies playing this role of end users, 2 of them in Italy, Novamont and Nadir. And last but not least, we have Avantium in the Netherlands. We are really pleased today that being represented by Avantium in this workshop. So I just leave the floor to Mr. Gert-Jan Gruter so that he can dive a bit in the main topic of the workshop. Thank you.
Thank you. Gert-Jan Gruter, are you ready?
Yeah.
Good.
Can you hear me and see the slides?
Yes.
Okay, then thanks for the introduction of the project. I will take it a little bit broader than the Cosmos project, because we have been active in CCU, carbon capture and utilization, already for quite some time. Avantium is a technology company. We are commercializing technology. Here you see an example of a plant that we're building in the north of the Netherlands. It will be started up later this year for the first production in the world of a bio-based building block for making polyesters. But next to that, we also work on the only other alternative for fossil, that is CO2 as feedstock to make monomers for polyesters with very good properties. And here in the bottom, you see you can call these materials solar chemicals, electromonomers, or wind polymers. So very interesting that you can make materials with a very good performance out of CO2. We use ambient temperature electrocatalysis for that. And yeah, there are lots of advantages. I will not go into detail, but CO2, of course, is if you compare it to lignocellulosic biomass, is extremely well defined. That's really a benefit. We have no competition with food, land use, deforestation, and GMO. We run the process at ambient temperature. That means we can change, let's say, the rate of the reaction and also the energy that we use depending on the energy pricing. We call that peak shaving. That's also not possible with conventional technologies. So there are quite some advantages. So if we look at COSMOS, Avantium is interested in the platform molecule oxalic acid. And we can also make that from carbon monoxide. That's also a route that's commercially used for fossil oxalic acid. That's what Avantium focuses on in the COSMOS project. We have also worked in a European program that has been finished called Ocean, where we made oxalic acid via formic acid, via formate, and then going to glycolic acid, which is for us the leading monomer that we are interested in. And the reason for that is that we have really interesting combination of properties that is not, doesn't exist for fossil analogs today. So the material is closed loop recyclable, home compostable, marine degradable, extremely good gas barrier, and it's of course interesting if it's CO2 based. And then the last option is that we also work on a direct conversion of CO2 to oxalic acid in the European project RECODE. Interestingly, why oxalic acid? We think oxalic acid as a platform molecule for plastics is really interesting. It's bifunctional, what you need for making polyesters. But interestingly, the amount of energy that you have to invest to convert CO2 into monomers is lowest of all options. And we only need 4 electrons to convert 2 CO2 molecules to oxalic acid. And we have 100% atom efficiency. So we retain all of the mass of the CO2. And that's very important because if you go to CO2, to ethylene from CO2, then you have per CO2 a 12 electron, a 6 electron reduction, but you also lose all the oxygen. So you lose a lot of mass. So you have to convert much more CO2 to make a ton of product. And that translates into a 10 times higher price, energy investment cost of making ethylene versus oxalic acid. So we believe that if you start from CO2, that the future winning materials, winning molecules will be oxygenates, the monomers for polyesters. So where are we? We are working on container-sized units, TRL 5-6, and that we also test at location in connected, for example, to carbon capture demos. In this case, in Germany, in the Ocean project. And also we had another European project where we tested that with a cement plant in Greece. So let's quickly go now to the most important part of this seminar, and that's about regulatory. So what is happening with respect to the climate and also the polymer growth, and these are two opposite trends. So we need to reduce fossil emissions. What you see here is the yellow is the decrease that's needed in CO2 emissions for the Paris Agreement, and here you see the growth in polymers probably leading to more than 1 billion tons in 2050. And if we phase out fossil, then we have only CO2, biomass, and recycling. And interestingly, Nova Institute predicts there's more volume potential for CO2-based materials. And of course, if you make that from biogenic CO2 or CO2 from the air via direct air capture, and you use renewable energy for the synthesis of these materials, then you also can play a role in the negative emissions that will be needed for a net zero future. That's the white dashed line. And then it's interesting to talk about what are negative emissions. And just one example from Andrea Ramirez. I know her well. I agree with everything in the paper, except that she, for example, here says that the removed gases are stored out of the atmosphere in a manner intended to be permanent. I think that's something that we have to be really careful for, because then CCS will always be better. So I don't agree with permanent. And the reason for that is when you look at the volume potential that you can see here for these CO2-based materials, at 2.3 gigatons of CO2 for the material in 2050. And then at the same time, you see that the amount of plastic that is in circulation is about 7 times the annual production. That means that there is a pool in the future of 10 gigaton or so of CO2 materials that are in use, even if the materials after 7 years become CO2 again. And the reason for that is that in the coming century, we will be in a growth mode in this transition. So I think it's very important that we are not going to focus on only permanent storage to recognize the negative emissions. It's easier for the calculation, but the pool in polymer volume is so large that it's going to be a very important component in the negative emissions that we need. To address the challenges, I think what is also very important is that there will be a competition with CCS. It's interesting to look at this book where they talk about net zero is not enough. And I've given that here. The current industry is really not looking at emissions at all, emission reductions. So the emissions are even growing. There are new fossil complexes built, 3 billion invested by INEOS in Antwerp for a new cracker. So their strategy is to continue what they do and to compensate by negative emissions, which just is a cost. And I think that is something that we have to be really careful for, also with respect to regulatory, is that net zero does not mean continuing what we do and more CCS, but we really need net zero to really compensate the emissions that we cannot avoid. Also, I think what is important is that if there will be higher taxes on CO2, the incentive for the companies to do CO2 storage will they can pay more for that CO2. And we also have seen already in our discussions to get access to biogenic CO2 that we are in competition with CCS. And a lot of companies say, why would I not do CCS at 200 euro per ton in the future instead of investing in new technology with all the risks associated? So I think it's very important. We have seen that with biomass, that it was much better to burn biomass to get energy and a lot of subsidies than to use the biomass for making chemicals. There was an uneven playing field. And I think we really have to avoid that will also happen for CO2.
Mr. Gruter, last minute, please.
Yeah,
thank you.
That was the last thing I wanted to say. Thank you.
Well, that was very succinct and very to the point. Thank you very much, Mr. Gruter, for your input there. Appreciate that very much. So next, we are going to move on to Mr. Oscar Ramirez from the CATCO2NVERS project coordination. He's a senior project manager at Funditech. And then we will pass the word not to Asli Özker, but instead Didam Bilic, representing Evyap. There it is. Yeah, super, Didam Bilic. Thank you. Oscar?
Okay, good morning. And Thank you, Francesco. First of all, I would like to thank you to prepare this webinar because it's very important for us as a coordinator, where hopefully we get excellent conclusion after this meeting. Okay, I'm going to introduce the CATCO2NVERS project. Okay. The concept of CATCO2NVERS project is based on the transforming waste CO2 from two bio-based industry into 5 added value chemical with application in chemical, cosmetic, and plastic industry. The consortium is formed by 15 partners from 8 different countries. Among them, there are 4 RTDs, 1 university, 8 SMEs, and 2 large enterprises. The bio-based industry represents a real opportunity to implement the CO2 reduction technologies. That's why CATCO2NVERS involved 2 industrial bio-based plants processing 2 types of biomass in order to obtain CO2 from 2 different sources and different concentration. The CO2 generated will be used in 5 different technologies. The first technology uses electrocatalytic process to transform CO2 into glyoxylic acid. The technology 2 use biocatalytic process to transform CO2 into lactic acid. The technology 3 and 5 use a thermocatalytic process to transform, in the technology 3, CO2 to cycle carbonate phase. The technology 4 transforms CO2 in furan dicarboxylic dimethyl ester, sorry. And the technology 5 transforms CO2 to biomethane. So the chemical obtained during the project is glyoxylic acid that we tested in cosmetic formulation. The lactic acid will be tested as well in cosmetic formulation and also in the synthesis of biopolymers. The FDM will be validated by industrial partners as monomer in the synthesis of PEF. The cycled carbonate will be used to synthesize polyurethanes. It will validate by industrial partners in the synthesis of pures. Biomethane will be used in bio-based industry. The project started last in 2021, where it is more in the month 34. It will conclude in April 2025. If you need more information or you have any doubt, please, you can contact me or my colleague Dulce Munoz, who is the technical manager. Thank you very much. Gracias.
You were mute, Francesco, but that should be absolutely done.
Thank you. Yes, I just passed on the word. I said thank you, Mr. Ramirez, and we pass the word now to
You're welcome.
To Didam Bilic from Evyap. Thank you.
Thank you, Francesco. I'm Didam Bilic from Evyap company. I'm R&D project manager responsible from Activex and other liquid personal wash products. I'd like to give you a brief information about Evyap company. In 1927, Mehmet Rifat Evyap started his journey with soap. Today, we have in many categories ranging from soap, shower gels, shampoo, shaving products, skincare creams, toothpaste, and baby diapers. Evyap exists in more than 100 countries with Duru, Arco, Evybaby, Fox, and Activex brands. In addition to establishing the world's largest oleochemical plant in Malaysia, Evyap produces in 3 different countries worldwide, including Turkey and Egypt, with the systems compliant with European standards. Evyap holds Turkey's fourth largest private port and maintaining its place among Turkey's top 100 industrial companies, with over 3,000 employees and engaged in contract manufacturing for leading companies worldwide. Evyap emphasizes the more efficient use of natural resources with its innovative work and investment. It also engages in research and development activities. This is our facility and R&D center. Today's agenda is for lactic acid and glyoxylic acid. For lactic acid, we have two regulations. One is cosmetic and the other is biocidal products regulation. We have two forms of lactic acid and we use in our factory L-lactic acid in biocidal products in Activex liquid hand soap, antibacterial soap. Also, D-lactic acid is used in cosmetic products and also as a food additive, feed additive, and in detergents and also in pharmaceutical industry. This is causing cosmetic ingredients list. As you can see, lactic acid can be used as buffering, humectant, and skin conditioning agent. This is the TDS technical data sheet of our L-lactic acid raw material that we use currently in our antibacterial liquid soap. And this is the legislation for biocidal products for L-lactic acid. Its purity is important in this case. And also there is some CLP classifications. These are changed in 2020 and hazard codes are like this for L-lactic acid. And this is our product. Activex is our antibacterial brand produced since 2009. It gives 99% effective against bacteria and fungi. And it's the leader in Turkish soap category. Also, it's effective, it protects the good bacteria on the skin. These are the bacterial tests, bacteria and fungi efficacy tests. We do these tests according to procedural principles declared by Turkish Ministry of Health. And we put this table also in our label. Application area and form, application dose and frequency amounts are important for the consumers. While in the registration to Turkish Ministry of Health, we also give a lot of information about lactic acid. We give the identity, physical, chemical properties, detection and identification methods, efficacy values, toxicological profile and ecotoxicological profile, measures required to protect humans, animals and environment. Also, classification of the raw material. According to this, we get the registration for our product. And for glyoxylic acid, this is related with the cosmetic products regulation. It's used in hair straightening cosmetic products, hair care shampoo type of products. Also, its purity is important. There are some limits about formaldehyde content. Also, it can be used in other skincare products too, to brighten the skin, fill the wrinkles in the skin, prevent moisture loss of the skin, and increase hyaluronic acid production in the skin. Also, it's listed in causing with antistatic buffering and hair waving or straightening functions. This is technical data for lyoxalic acid. Also, its purity is important for high quality products. We do some tests for our cosmetic formulations. We do stability tests at these conditions. We also do cycle tests and sun tests. Also, microbiological criteria and challenge tests are important for the preservatives. Also, we do dermatological tests, and in some products, we do hypoallergenic tests and also flame substantiation tests. And there are some limits for cosmetic products for heavy metal reasons. Because of that, we check for the raw material technical data for these issues. And for all cosmetic products, our safety assessors, safety assessor check for the safety assessment and prepares a report. In this report, usually we check for the raw materials, the cosmetic annexes. If it's considered safe, it's okay. But also we check marginal safety value. This is changed according to the target group. And our safety assessor checks for the NOAL values and calculates most values according to these, according to all raw materials used in cosmetic products. These are the regulations we follow. Our national regulations are also in compliance with European Union regulations. These are all the regulations that we go through. And these are the references that I shared with the biocidal products dossier. We prepare the dossier according to these references. Thank you for your attention.
Excellent. Thank you very much, Didem Bilic. Appreciate that very much. And that's something for us to think about. And now I'm going to pass the word to Albert Cusasola from VIVALDI Project Coordination. He's a professor at the Autonomous University of Barcelona, who will then pass the word to Elvira Sadler, Principal Consultant at IL Utilities. Thank you. Albert?
Thank you. Good morning. I hope you can hear me well, and thank you, Francesco, for the organization. So, I cannot. Maybe you can do it for me.
Sure. Wait, and try again. Okay.
Good. Okay, so this is a short overview of the VIVALDI project, which I am coordinating. It's an European project, like the other two projects that have been presented today. I cannot pass that. Okay, so the objective of this project is to transform CO2 from bio-based industries into 4 organic acids. And the first step is the purification and conversion of the CO2. We are going to do it through electrochemical processes. And we are going to also use the wastewater as a source of nutrient, because these nutrients will be used. Can you go? I have a lot of animations that I cannot control, so that's a bit tricky for me. Can you put all the slides? Yeah, that's better. Okay, so what we are going to do is use the CO2 from bio-based industries and nutrients from wastewaters. We are going to use them as a sources for fermentation process. And what we are going to do first is a electrochemical conversion of CO2 to formic acid and to methanol, and this will be used as building blocks for the conversion of this formic acid and methanol to the 4 organic acids. And these organic acids will re-enter to the industrial chain. Next, please. Can you put all the slides? Yeah, sorry, it will be better. Okay, so we are going to use 4 different technologies. The first technology is CO2 electroreduction. We are going to reduce CO2 to formic acid and methanol as building blocks. We are preparing new catalysts. We are preparing new cells for that, and we are in progress of that. The second technology that we are going to be using is bioelectrochemical systems for the recovery of ammonium from high strength wastewaters, and we are going to recover several cations through the bioelectroconcentration process. So, and this will be fed to a fermentation process. This fermentation process can have a lot of different microorganisms. We are going to use yeast, in this case, the Evyap pastorius yeast, and we are going to transform them into these 4 organic acids. These 4 organic acids, we chose them because they have different market penetration shares. We have lactic acid, which of course has a high market penetration. Then we have, sorry, can you go back? Thanks. Then we have succinic and itaconic, which are, let's say, mid penetration market. It's the present of these acids. And then we have 3-hydroxypropionic acid, which is a top, which is a future platform acid. Okay. We are also preparing the downstream processing. And finally, in the last year of VIVALDI, we have the industrial validation of these acids with end users. Thanks, Lara. Why did we choose CO2 electroreduction? Because it has a high kinetics. So with a low input of energy, we have a high conversion, a high fast conversion of the CO2 to formic acid and methanol. And why did we choose formic acid and methanol as building blocks? Because they have a high market price. They can be sold as standalone products, and they have a lot of energy content. Next, please. Okay. Bioelectrochemical systems is a very emerging technology to recover ammonia and nutrients from wastewater. And what we are going to do with that is to close the circular assessment of the project. Next, please. And Evyap pastorius as a fermentation agent is a very known fermentation agent. It can grow on simple media. It's already industrially scaled, so we can really work with them to produce the acids that we want. So these are the 4 target compounds. As I told you, it's a very different market penetration shares and with very different uses, but they have all in common that they are going to be precursors of bioplastics. And finally, my last 2 slides, is to show our consortium. Our consortium is 16 partners, which, as the other projects, include bio-based industries that are CO2 emitters or producers. I don't know which is the best word for that. Then we have technology developers and users and knowledge hubs. And this is the summary slide. I know there is a lot of information here, but you can see the bio-based industries. You can see the technology, the developers from all around the world, the end users, and the knowledge hubs. So thanks. I'm sorry for not being able to control the presentation. It worked 1 hour ago. I'm sorry for that. And I give the word to Elvira, which is one of the knowledge hubs of VIVALDI project.
Thank you, Albert.
Thank you so much. If I could just speak over you quickly for a second, Albert, thank you so much. I just want to repeat the invitation to all the participants to please, if you have questions, enter them already now into the Q&A bubbles at the bottom of your ribbon over there, controlling the Zoom. Please enter your questions. We look forward to receiving your questions so that we can order them and then pass them through to the Q&A session. Thank you. Back to you, Elvira Serra, the Principal Consultant at IL Utilities. Thank you.
Thank you, Francesco. So yeah, my name is Elvira Serra. I work in IL Utilities, and we are leading the work package on the market and also on designing the business strategy for the Vivaldi solutions and products. We work together with CO2 Value Europe, but they are like more focused on the regulation aspects of the project. So the idea of this presentation is to provide a little bit of overview of the work that we have done around the market opportunities and potential barriers for the uptake of the CO2-based products produced in Vivaldi. So yeah, so for the market analysis approach, we have been looking not only at the CO2 market, so we have looking at the value creation from CO2, and also we have been looking a lot. I have a little bit of issue on seeing the whole slide, and yeah. So,
yeah, maybe there's the animation that maybe it glitches with the program, but
yeah,
I'm here to help, no worries.
Okay, so we have been looking at the value creation from CO2, and also we have been looking at like the opportunities and barriers for the CO2 products and intermediates, the market for them. My main focus, the first part of the presentation is going to be on the CO market. So here you can see that in 2021, like the capture capacity of CO2 was around 43 megatons of CO2, and the final application was mainly on enhanced oil recovery. The perspective of the is that by 2013, the amount of capture capacity is going to increase around 2079 megatons of CO2. That only represents 0.6% of today's emission. So it's not going to be enough to capture all the CO2 that is emitted. And also you can see here that for the CCU, for the utilization of the CO2 is expected that there's going to be an increase on the capture and utilization of this CO2, around 33.48 megatons of CO2. And there is a change as well between the storage of CO2. You can see that there is an increase expected by 2030 of more projects or more applications of the CO2 on a storage. Let me try to... Yeah, so also you can see in this slide that although the CO2 capture and utilization is expected to increase by 2030, it's not going to be enough to capture all the CO2, but there is a promising market for the CO2 derived products and services with a market around 1 and 7 gigatons of CO2 that can be available for the production of derived CO2 products. The technologies that or the methods for valorization of this CO2 are focused on... No, did I change it? Sorry. No. Sorry. So the methods for valorization of CO2 are mainly focused on 3 processes. One is the thermochemical conversion, another one is the electrochemical conversion, and the third one is biological conversion. You can see in the next slide. No. Yeah, it doesn't work really well. Sorry about that. Yeah, so you can see in this next slide where that the thermochemical conversion for CO2 valorization is the method or process that most of the companies have been focusing on trying to develop technologies to capture the CO2 and produce another value product from them. And there is like a range of level of development in these technologies from lab scale to commercial scale. In the case of Vivaldi, you can see that we sit between the electrochemical and the biological solutions, because Vivaldi has a hybrid approach to produce added value products, in this case, organic acids. And this type of hybrid technologies at a really pioneering stage, which means that there is a lot of potential for them to be developed in the future. So we have been looking as well as which are the market influences for these CO2-derived products. The first market influence is around like the CO2 source. It's really important, the origin of the CO2 feedstock, and also like the purity of this CO2, because that has an implication on the cost of the technology, and it's around 90% of the total cost of them. So here we have put like some prices around direct air capture, which is the prices method that you can use for carbon capture. And depending on the source of the CO2, you can see the differences around the price, and mainly are linked to the purity of this CO2. Another parameter that impacts the CO2 derived products is hydrogen. So it's really important for the production of CO2-based fuels and chemicals to have a cheap renewable energy, just to reduce the cost of their production. And the most eco-friendly choice right now is green hydrogen, but this green hydrogen is using renewable energy and electrolysis, and the price of this hydrogen is around 2.5 and $6 per kilo of hydrogen produced. And also it's important to know that the prices of hydrogen differ across regions. So the price of the renewables energy impacts the price of the hydrogen that you are going to use for the production of CO2. Another influence that or parameter that impacts the market for the CO2 derived products is the scalability. So the fact that this to make this solution sustainable, we need hydrogen and also like the CO2, obviously, it requires a large transport infrastructure, which has a cost associated to that. But there are opportunities around clusters, because these clusters can optimize the efficiency and also reduce the cost of the infrastructure that is needed for the production of these CO2 products. In terms of like drivers for the market for these CO2 products, they are a road to net zero, so they support this policy around reaching net zero by 2015. There are also like some advantages of the CCU over the CCS, since the CCS is seen as a technology that has a high capex and also OPEX, and also all the costs associated to the capture and the pipeline that is needed for the storage sites. Also, a driver for these CO2 products is that the conversion of this CO2 produce a product that is it has a market, and it can generate a revenue stream for the industries that are implemented that. And also, like, there is a bottom-up scenario that is these opportunities, and it can be a higher demand for these CCU technologies, since they are going to be able to produce a large volume of chemicals that are needed for the industry, and also they can support the industry to reduce the CO2 emissions. And also, one of the drivers for them is that they can be tailored to the different industries and to the specific CO2 streams. In terms of for Vivaldi, there are additional drivers that we have identified. So one of the drivers for the implementation of the solution that is developed in Vivaldi is this approach, this hybrid chemical and biological approach that have high specificity, and also it can have like a higher energy efficiency. And also, like, it can be integrated in biorefineries and can support the mitigation of biogenic CO2 that is emitted by biorefineries in Europe. And also, it has this approach of industrial symbiosis, since the Vivaldi project is not only looking at the CO2 generated by the bio industries, but also is looking at using the wastewater produced there to support the production of the organic acids.
Elvira, I think I need to bring yours to a close now. You want to do a final sentence, please?
Yeah, maybe, like, I can just finish with these barriers for the products. And yeah, maybe we can leave this slide here and that's all. Yeah.
Okay.
Thank
Please
you.
continue.
Do you want me to continue? It's like,
if you want to summarize in one sentence, and then we can move on.
So yeah, so then like some of the barriers are linked to the maturity of the technology. So there is a diversity of maturity levels of maturity in the technologies for CCU. Also, another barrier is associated to the source of energy, that is hydrogen, and it's a costly energy source right now. Also, the barriers associated to the point of resources, like the cost of the CCU technology, depending on the type of industry, and also like the quality and purity of the CO2. Then also like the fact that CCU sometimes is seen as a complementary to CCS instead of like a competitor. And also then the emissions concerns associated to the fact that the CCU products are not seen as a long-term storage of CO2. And then the fact that CCU is competing with conventional production paths that are less expensive than the CCU applications. And
excellent.
That's all. Yeah.
Thank you. You got it out nicely in the summary. Thank you very much, Elvira. Now I'm going to pass the word to Algret Dumais. He's the Policy Officer at the European Commission's Directorate General for the Internal Market, Industry, Entrepreneurship and SMEs, known as DG GROW, working in Unit F2 Bioeconomy, Chemicals, Cosmetics. Within the Directorate, he focuses on transition pathway for the chemical industry in Europe. Mr. Dumais holds a MSc in Economics and Business Administration, and brings expertise in chemical policy and legislation, as well as deeply rooted experience from the private sector, having worked with global companies and startups in the energy, financial, and pharmaceutical industries. Mr. Dumais, I pass the word to you.
Thank you very much, Francesco, and I'm happy to be here and present the transition pathway for the chemical industry in this context. Just to make you understand what the pathway is, I think it's very useful to provide a little bit of background around this exercise that the Commission has been carried with stakeholders. And that's a very important thing. The pathway is it was a co-creation exercise. It was not something that was based on a top-down approach. We rather developed it in strong collaboration with stakeholders, including the chemical industry itself, NGOs, member states, and so on. And why we did it? We did it because of the policy context of the updated industrial strategy, which set out this ambition to develop action plans to show how a certain industrial ecosystem can reach the twin transition. And the chemical industry had the priority on this, of course. And there are different reasons why that you might obviously know, which is basically the fact that the chemical industry is at the beginning of the main strategic value chains that will enable eventually the Green Deal ambitions. And at the same time, the chemical industry is facing a particular landscape, which is challenging both from a competitive perspective and also from a regulatory perspective. On the competitive perspective, we have the issue of resiliency and supply chain dependencies, especially when it comes to fossil fuels, and the market share in parallel is steadily, slowly declining. At the same time, and we can move to the next slide, the chemical industry is factoring in a lot of regulation and policies to deal with the Green Deal ambitions, including, for instance, the revised ETS, all the Fit for 55 package, the chemical strategy for sustainability, and so on. So we need something that somehow can balance out the equation between sustainability and competitiveness. And that document is the transition pathway, which was published in January 2023. So as I outlined before, the pathway is in a nutshell a roadmap. It has around 190 actions which show what industry, member states, and also the EU should do in order to make this twin transition happen, but also maintain the competitiveness and resilience of the EU chemical industry. And it is structured around 8 main chapters. One focuses on, we can just stay on the previous slide, thank you. The first one focuses on competitiveness as such. Then we move on to investment and funding, so how to create better enabling conditions to access new funding, for instance, how to better communicate on it and streamline the process. And then research and innovation, regulation and governance, which focuses pretty much on how to ensure regulatory coherence, both vertically and both horizontally. Then energy and feedstock and infrastructure, which are, I think, very high priority topics of our transition pathway for the chemical industry. And last but not least, the skills dimension and the social dimension. So just to give you a little bit of a sketch of how the pathway is structured, we can move to the next slide, which is about the research and innovation chapter. It focuses pretty much on how to devise a policy framework which can allow to develop but also uptake technological solutions for the chemical industry. So we have structured it into 3 topics. One focuses on low TRL levels, then move to higher ones, and then to the deployment, so 9 to 10. And at the first stage, we focus pretty much on the development of new concepts. And in the chemical industry, we have the ongoing work under the Safe and Sustainable by Design framework, which is led by RTD. And this focuses pretty much on what are the innovation principles that should be followed in order to create chemicals which are safe and sustainable across the entire life cycle. It's still under development. The criteria are not there. We are making testing phases with the companies which are working on how to establish what these safe and sustainable by design chemicals are. So this is pretty much low TRL level focused, and it's at a conceptualization phase. And then we have the development part and also the deployment part. In this case, we put emphasis a lot on public-private partnerships, such as the Circular-Based Europe joint undertaking, and also financial and regulatory support. So we can move to the next slide to show it a little bit more in detail. Lara, thank you. That's pretty much what I briefly explained, and you can see here also the references to the SSBD and to Circular-Based Europe. But I think what is more relevant now is to translate this strategy into execution, and it is the most difficult part, and that's the co-implementation of the pathway. So next slide, please. So the co-implementation is basically 5 elements. One, it's, let's say, a basic ingredient. So it's a process which is done in 3 levels. Actions have to be taken at industry level, EU level, and also member states level. And to promote this collaboration, we will establish a specific Commission expert group where industry is represented by trade and business associations. And this expert group is important to set up the governance and also set up the priorities of the process. In the meantime, in order to incentivize companies to let us know what they are doing for the transition, we launched a call for transition initiatives. That means we ask companies, but also the public institutions, about what are their projects and investments which are related to the objectives and actions of the pathway. Then in the meantime, we work on more analytical aspects that entail the pathway, which are the task forces. So we work with industry and also NGO member states to perform certain analysis which can eventually inform our policy making. And we take all these inputs into account to inform also the development of our Commission next working programs. And this will be done through an annual progress report. To go back to the task forces, there are 3 main exercises that we have done last year. And there is also another exercise that we will do this year. So we worked on a set of KPIs which can be used to monitor the implementation process, and they focus pretty much on the competitiveness of the chemical industry. So aspects such as market share, changed investments are taken into account, but also aspects related to the twin transition as such are considered, such as the uptake of bio-based feedstocks. And then we have another work which analyzes specifically what are the energy and feedstock needs of the chemical industry to achieve the 2030 and 2050 goals. And we have to consider also how to factor in also the 2040 target in this analysis. And this work is done in close collaboration with CEFIC. We probably will rely on their modeling, which focuses on basic chemicals and the technological pathways to produce such chemicals. Then we have also a task force on circularity, which has mapped out what are the main pieces of legislation that are related to CO2, bio-based and waste feedstocks. And now we will take the outcome out of this exercise, and we will start to see what are possible market pull measures to promote the uptake of CO2 waste-based and bio-based products. So this work has not started yet. We'll start at the end of February. And we will start seeing how we can, for instance, design a certification scheme, standardization, or eventually also how to boost green procurement. And an example would be taking some inspiration from the Biopreferred program in the US. And finally, last but not least, guidance on funding. This is a document that we've prepared. We want to publish it as soon as possible. It essentially shows what are the main EU funding schemes that can support the chemical industry for the twin transition, then also the open calls and all the calls that were closed, because we do see that it's still useful to keep track of the type of projects that have been financed, so that companies have a better direction of what can be supported under EU funding. So we can move to the next slide. Yeah, that's pretty much what is the outcome from the call for transition initiatives we got. I will be very brief on that. So this is pretty much an ongoing exercise. We collect initiatives on an ongoing basis, and we use them for our annual progress report. And at the beginning, we obtained a lot of initiatives from industry, but we will publish more initiatives as we move forward with the implementation process. So these are just preliminary results that we got. We can go to the next slide on funding. So this is just a quick sketch of the main funding programs we have. I would put a lot of focus on the Innovation Fund and the Horizon Europe for the time being, because for the Recovery and Resilience Facility, it's a big program, but of course the implementation is done pretty much on a member state level. So it's more difficult to track from our side what is currently done under this scheme. And I would say that's why I say that the Innovation Fund, Horizon Europe are those that are probably based on our research and the guidance we have, which are the most relevant for the chemical industry. Of course, our role can be played also by the Digital Europe program and the Single Market program, which are respectively relevant for the digital transition, and the single market is more relevant for horizontal issues for SMEs, such as training. And finally, we can move to the next slide. Yeah, that's a regulatory roadmap. So I think I hope it's not too small. That's essentially what we have in the pathway, but this is an updated version, which shows what are the most relevant pieces of legislation for the chemical industry based on the best available knowledge. And this was presented in December, on the 1st of December, and we will update it on an ongoing basis. It shows essentially the pieces of legislation, the time for adoption for the Commission, and then the time from entry into force and how they are applied in time. So here we have the CLP revision and also the SSBD framework. Then on the next slide, we have a major focus on the different pieces of legislation under the Fit for 55, for instance, of CBAM, ETS, and so on. And also the Social Climate Fund that was announced in parallel with the revised ETS, which will enter into force from 2026 based on the announcements. So final slide, that summarizes essentially where we stand. So as I mentioned before, we expect to publish the guidance on funding by the end of February. We will present in the plenary meeting with stakeholders our annual progress report on the 18th of March, and we will carry over this exercise also through the rest of the year, of course. And we take, as I mentioned before, we take stock of all the input to provide possibly feedback for the working program of the Commission. So, and we also ensure at the same time that this exercise doesn't stay as a separate silo, but we inform all the Commission services as DG GROW. So I think this is very important to improve our policy development. And I think that's the main objective of the co-implementation. At the same time, I would like to conclude with some key messages. So, as I mentioned, the pathway is truly important as a starting point to build a business case and find out what is truly needed to achieve the twin transition and also maintain the competitiveness of the chemical industry. And it's truly important that every stakeholder engages as much as possible. So we would also welcome, if possible, for you to provide your transition initiatives and answer the call and provide substantial input to our mapping exercise. That's pretty much from my side, and thanks a lot for giving me this opportunity.
Thank you very much, Avantium. Thank you for taking the time to join us here today. It's very, very helpful. And we hope to hear more from you as it progresses. Now, we finally arrived at the question and answer session. I'm now going to pass the floor to Policy Director from CO2 Value Europe, Tudi Benya, who will moderate the Q&A session.
Thank you very much, and I hope that you can hear me well. If it's not the case, give me a shout. Okay, thanks a lot. So for the next 30-40 minutes, what we wanted to do was to take the opportunity of all the presentations that we heard to take your questions and to try to answer them. And so I've seen that in the Q&A, we already have a number of questions, but don't hesitate to keep them coming so that we can inform, let's say, our discussion and continue to pick your questions. They can be both on, let's say, the more technical sides of some of the presentations that we saw, or let's say more on the policy and regulatory side, so that we can exchange as well and discuss with the policymakers that are present and in particular Algred. And I wanted to start by this, Algred. So first of all, thanks a lot for taking the time and for coming to present the transition pathway. From our perspective, I think you heard that as well from the different projects. We think that it's really important that those elements come together and that there's both like policy mechanisms, funding mechanisms, that there's all of this kind of value chain that comes together. And so maybe the first question that I wanted to ask you is, from what you heard in the different presentation, and thanks a lot for taking the time to be there for the presentation of the three projects. Do the presentation resonate with the work that the Commission is doing in the transition pathway? For example, we heard from the colleagues of Avantium elements around the need to have a carbon feedstock in the future, for example, for the production of plastics. Are those elements that you see as resonating with the work that you're doing in the transition pathway? Are those elements that are integrated, let's say, in the work that the transition pathway is doing?
Thanks a lot, Tudi, and absolutely yes. As I mentioned before, we have two work streams that are specifically tackling issues which are related to CCU. Just to start, of course, the pathway in itself recognizes the importance of using carbon out of CCU from both industrial point sources and from the air. What we're trying to do now is to see what we can do both in terms of technology push, and in this case we have the funding work that we've done to map out what are the relevant calls that can support eventually CCU technologies. But then of course we notice that it's also important to have some market pull on the side. And this is also something that has been flagged out in the recently adopted industrial carbon management communication strategy. So in the pathway, we want to do it in a more, let's say, collaborative way and speak directly to industry and see what we really need in terms of market pull to enable the use of CO2 as a feedstock for the chemical industry as an alternative to fossil fuels. So it absolutely resonates, and I think also the data that you've provided can be used somehow, or at least can be considered for the task force which is working on energy and feedstock, because in that case, of course, it's a mathematical exercise. It has some limitations, and it has to be seen what are the technological pathways and chemicals related to those technological pathways where CCU can be used. I'm just thinking out loud. Yeah, eventually.
No, go ahead.
Yeah, I mean, I'm just thinking, for sure, if I recall it correctly, we have methanol, but then we will have to see actually to what extent CCU is factored in. But I think we have different work streams whereby carbon capture utilization is extremely relevant.
Yeah, thanks a lot. And thanks also for bringing up the industrial carbon management strategy. So I don't know if everyone on the call has this in mind, but so on 6th of February, the European Commission published two very important documents, one on the EU targets towards 2040, so a recommendation for a reduction of 90% of GHG emissions by 2040 in Europe. And this document came with the industrial carbon management strategy, which looks more precisely at CCS, CCU, carbon removals, CO2 transport, and so on. And so to make the link with that and the kind of market pull mechanisms that you were mentioning, Algred, there's one question in the chat maybe that can make the link. It's from your perspective, or from what you know that the Commission is working on, and for example in the industrial carbon management strategy, do you does the Commission believe that creating more incentives or more quotas, for example, for the use of alternative carbon feedstock is one of the ways to go? I mean, we know, for example, that in other spaces for CCU, for example, for CCU fuels, for applications that are hard to electrify, like aviation and the maritime sector, Europe has now created quotas, saying, for example, to airlines and to fuel producers, well, for planes in the future, we will need to use CCU fuels, meaning essentially, for example, e-kerosene that has been produced from renewable hydrogen together with captured CO2. Do you feel in the discussions, and I know that it's not only DG GROA, right, that is working on that, but do you feel that it's one of the elements that can come, let's say, to feed the discussion and the legislation to say, okay, what we've done for fuel, for example, for specific sectors that are hard to electrify, we should do the same for the chemical sector, and we should have those type of incentives and quotas in place for alternative carbon feedstock?
Thanks a lot, Tudi. Well, and thanks also for reiterating the point that, of course, establishing then the targets is something that is not only up to my unit and DG GROW, but there are also other DGs involved. Actually, this is something that somehow has already been historically reflected. If you think, for instance, about the sustainable carbon cycles communication, where there is this idea of this 20% target for non-virgin fossil fuel carbon, also for chemical products, if I recall it correctly. So the question whether a target is a good solution or not, I mean, it's still to be solved, but certainly it's taken into consideration in different work streams of the Commission, and also in the pathway implementation process has been already mentioned several times. And also this dynamic with the fuel sectors and the targets for sustainable aviation fuels has been considered. And this also might affect what we do in terms of estimates for energy and feedstock needs for the chemical industry, because of course this affects also the availability that you have of a certain feedstock.
Okay, yeah, thanks. And I have two more from you that I see from the chat, and then we can go to other questions so that you can also rest a bit. But the two other questions that I see from the chat that I wanted to ask you, the first one is, the question was, have the differences in regulations across member states already been cataloged? So I guess the question linking it to the transition pathway is it also part of the work that the transition pathway will do to try to map what is happening, for example, at national level, or are you more looking at, let's say, the EU remit?
We are actually looking more at EU remit, the work on, but of course we pay attention also to what happens at national levels, but this is actually done more by national industry associations that are developing with member states' national transition pathways.
Okay, very
so it's
clear.
not that by us.
Okay, and then the last one that I had for you from what I see in the chat is there is a question around the Net Zero Industry Act and whether this provides, let's say, additional support or framework for the deployment of CCU technologies, and more broadly, maybe. So the question for you is the, let's say, the new elements that are put forward in the Net Zero Industry Act also feeding the work of the transition pathway? And to complement that question, my question would be, I know that in the industrial carbon management strategy, there is mention also of biotech and biomanufacturing as, let's say, one of the elements that the Commission will be working on. So not to get too technical, but I wanted to get a bit the feeling from your side of whether the latest elements developed and discussed in the EU policies discussion, are they also feeding the thinking and the work of the transition pathway?
Well, they are absolutely reflected in the transition pathway, and actually on the meeting of the 1st December, we explicitly touched upon a little bit on what are the main regulatory pieces which affect CO2 deployment as a feedstock, and also the NZIA was mentioned, and we are perfectly aware of what is going on, and we pay a lot of attention to it. Of course, in terms of development, now the DANZIA is with the co-legislators. So in terms of what will be supported, to some extent, this is something to be seen. And in parallel, also to mention that as you just pointed out, the bioeconomy initiative, I think it's really important to ensure synergies among these different types of feedstocks and whatever we are doing to replace fossil fuels. This is already included in the industrial carbon management communication strategy. If you see the text, there is a point which points out about the fact that we have to ensure alignment about it. And now we are working on the bioeconomy strategy, so the timeline is still Q1 2024, if I'm correct. And we, of course, in Pathway, we keep track on it as well. So this is also relevant for us.
Okay, thanks a lot, Alegret, and thanks a lot as well for taking the time to answer those questions. Maybe I'm looking at the questions that we see in the chat. Again, if you have other elements that you want to bring up, really don't hesitate to type your question in, and we'll make sure to address them. I just wanted to go to some of the more, let's say, technical questions or elements that have been brought that are more about the presentations that we saw. I think the one that I see in front of me is probably for the speakers from CATCO2NVERS, in particular from Evyap. And the question is, how different are the requirements for test and safety if the starting material is CO2 compared to, let's say, conventional equivalent? I don't know if it's something that one of the speakers from that presented from CATCO2NVERS can address.
Hi, I'm from Evyap. I can
Yes, go ahead. Yeah, sure.
I think according to safety and also cosmetic tests, regarding to cosmetic tests and regulations, in the final product, these are the same. We have to test all tests, and also according to legislation for our product, the conditions are the same. We have to check the stabilities, make all the tests, and afterwards, for biocidal products legislation, for example, according to these regulations, we have to get a license for this product too.
Okay, thanks a lot.
Thank you.
Maybe I should have said that, but if speakers on the specific questions want to weigh in, feel free to raise your hand and to enter in the discussion. It's really meant for you as well to be able to contribute. Another one, let's say more on the project side that I see in the chat, and probably colleagues from the Vivaldi projects or from COSMOS can try to address this. The question is the biogenic CO2 the only option for making new products? If CO2 pipelines are developed across Europe, how will the CTU integrate the network? I guess the second part of the question is broader, but on the first one, maybe one of the speakers from either COSMOS or Vivaldi want to take the floor on why focus on the biogenic part. What is the, let's say, what is the thinking behind this, and the value?
Yeah, if you want, I can get into it. Yeah, okay. I think that's a very, very good question, and I'm sorry, but it has a very simple answer. Is the three projects that we are presenting now come from biogenic CO2, because that was the call of the industry in Europe. So the call was related to biogenic CO2, and of course the three projects that we are presenting are based on that, because we were following the call. But of course, all of our technologies, all of our methodologies are not linked to only biogenic CO2. It can be any CO2, but we have to take into account where does this CO2 come from, and the purity and the possibility of, even if there is a small percentage of some impurities that affect the first step of the CO2 conversion. For example, in our case, the electrochemical CO2 reduction, you work with cathodes, and you work with sensitive material, that not all the impurities can go there. But I don't know if Martin from COSMOS want to enter into it, but the reasoning was very simple in this case.
Yeah, I agree, Albert, because for example, with the carbon dioxide that comes from combustion, it can have some kind of impurities that can affect negatively both the catalyst and the chemical routes, but also the fermentations, the microorganisms. So in the case of carbon dioxide coming from bio-based industries, this is, let's say, more control. And for other kind of carbon dioxide streams, we should check first the precise, the exact content, and try to adapt our solutions to the specific composition of these streams.
And
Yeah.
so no,
Yeah.
I was just going to make the link with another question that I saw. And sorry, Albert, I'll give you back the floor in a second. But I just wanted to make the link with another question that I saw in the chat, which was for the type of products that you're making, and I'm guessing that they have in mind either on Cosmos or Vivaldi. Does the CO2 that you're using, does it need to be pure, like to very, very high level, like 99.9%, or can it be lower? And maybe it links, let's say, back to using a biogenic CO2. Sorry, Albert, go ahead.
No, exactly. I was going to answer this question because I saw it in the chat as well. Yeah. The truth is that, of course, all the processes need to have a purification step because it's needed, but it depends on the impurities. For example, we have a case that we have only 13% of CO2 in our gas, but if the rest, if the impurities are not harmful for the electrochemical conversion, it could even be working like this. As Nicolas was saying, if we work with gas that comes from fermentation, it can be 96, 97, 98%, and the rest maybe can be water or maybe can be nitrogen, and this is not harmful. So we need purification step, a concentration step that can be done with absorption, it can be done with adsorption, it can be done with membranes, it can be done with cryogenesis. There are different ways to concentrate the CO2, and this is much more related to the impurities of the let's say of the original gas and how do they affect to the technical process.
Thanks a lot, Albert. Maybe a last one, let's say more on the technical project side, and I think this is for all the speakers from projects. So whoever wants to come in, feel free to. It's a question from Geert, who says, seems cost for application of CCU technologies are still high. What do you expect within 10 years from now for scale and subsequent cost? Will be expected to be lower, and to what degree? Well, I guess this is a very broad question. We know that the cost of CCU is something that is fundamental to its scale up and to its ability, let's say, to reach ambitions and high targets, for example, for the production of chemicals. I don't know if anyone has a perspective on that, and it's also something that will be very relevant for the policy part and how the funding and how the support mechanisms will be shaped. So I don't know if there's any of the speakers that want to address that. Yeah, go ahead.
I like to indeed say something. Yeah, so first of all, it depends very much on the product that you make. I've shown that if you make hydrogen, you invest 2 electrons and you make 2 grams of product. But if you do the same for CO2 and you make oxalate, that's also 2 electrons, you make 88 grams of product. So what product you make is very important. And I think certainly oxalic acid you can make electrocatalytically in a competitive way. But I think the bigger problem that I see is the competition with fossil, because the fossil producers, they just take a storage price as a sort of added cost, and then still they are going to head-on compete in the coming decades, I think, with these new technologies, and that is going to be really a challenge. In Europe, nobody is going to build a new coal energy plant, but the chemical companies are still investing in fossil because they just look at an extra cost for storage, and then they still have a better business case than a lot of the renewable options. So I'm very interested to hear that perspective. Why is there no roadmap to step out of fossil for the chemical industry while we have it for energy?
That's a very good point, and we can also maybe address that as well to our invitee from the European Commission, but I don't know if it's still around. But maybe in the meantime, is there anybody else wanting to weigh in on the issue of costs and what you see as the dynamics, let's say, for the different technologies that you're working on?
Maybe I can say something here.
Yes, sure, go ahead.
Yeah, so obviously, you know, like on the presentation, I've been like going through the opportunities and also for like the barriers, but obviously there are opportunities that we have seen for the technologies when we are just producing a product that really has a market and it can compete, as Gair said, with the conventional path. So we need to look at how the cost of a CCU technology is, and from there we can say, okay, this technology is going to be competitive because we are producing a product that has a market and the value of this product in the market is high and it can compete with it, it's already there. But also we apply this technology in certain conditions that it reduces the cost. So there are things like the capture of CO2, you know, and this is associated to which is the source of CO2 that we are using. If we have to purify the CO2, we are adding a cost to the technology. If and that, you know, makes this technology less competitive in the market. And what we have seen as well is like already there are technologies, CCU technologies in the market that they are commercially available, that they are working and they have a, you know, a market for them, and it's linked also to the product that they are producing. And we see that there is an opportunity for these technologies that are going to produce chemicals, but also we see that there is a huge potential if this is seen as a kind of like trying to cluster, you know, like if we have like not just one single bioindustry, we have several bioindustries that they cluster together and they support the implementation of these technologies to produce an added value product that can be commercialized. And this is how we see in terms of like the way that we have analyzed the market for the project and for the technologies that are being developed there.
Thanks a lot, Elvira. And while you have the floor, I wanted to take the opportunity to address another question that I see in the chat, which is on labeling and how to show, let's say, the value of CCU products or of CCU chemicals that you're producing. Are you able to share more from your perspective on, let's say, some of the challenges or the drivers or the barriers that you see for how to market, to label, let's say, the climate benefits from the products that you're working on?
So I think that the labeling is something that is happening with other products that are linked also to this circular economy approach. So we are producing products in other sectors that they are competing with conventional ones, but just because of the source of producing this product is a waste, they are seen in a different way. But unlabeling, I think that is a way to push these products to the market and give them like make them different. So like show that they are sustainable. So it's about more marketing these products as sustainable ones and saying these are the same, but they are more sustainable because they are coming from these sources of waste. And this, I think, that is the most important thing. Yeah, because we have seen in other markets as well. It's not just the CO2 market. It's other products produced in other markets, same quality, same composition, same characteristics, but you need to label some way to show that they are more sustainable than the current ones in the market. Yeah.
Yeah. Thanks a lot, Elvira. I saw that our colleague from the European Commission had to step out. But some of the points that were raised, and for example from the colleague of Avantium on the roadmap, let's say for how to decrease emissions and how to move away from fossil fuels essentially in the chemical industry, I think that the typical or the answers that we would get from the European Commission is one, industrial carbon management strategy is now setting a kind of a pathway or a kind of a perspective for how to decrease the reliance of chemicals on fossil fuels, and essentially putting forward as solutions CCU, CCS. There's a number of other levers, let's say, that are being promoted by the European Commission on this. And I think their other answer would be that it's the transition pathway for the chemical industry that Algret presented that will be one of the tools used by the European Commission to try to get the chemical sector to move forward. As Algret was saying, it's a complex element because you have different parts of the European Commission that are working on that, be it DG Klima, be it DG Environment, be it DG Grow, and so on. So it kind of all needs to come together. But I think it's a fair point that you were raising that since we have on the energy side a kind of a very clear perspective on moving away from fossil fuel, we need something more concrete for the chemical side to say, how will we actually reward and enable companies and organizations to claim benefits from, for example, reusing captured carbon versus using fossil fuels, for example, for creating one chemical. So that's something that we've been kind of saying and advocating for as CO2Valley Europe for the last 2 years at least. From our perspective, it's a very good signal that Europe is finally starting like really to look at chemicals as one of the, I was going to say blind spots, let's say one of the areas where more work is needed and where more incentives need to be created. I'm checking at the rest of the questions that we have in the chat. I don't know if something maybe that we can also feed in our recommendation to the European Commission. Do speakers see like specific sectors that, because when we say the chemical industry, we say everything, right? And so we heard in the different presentations people talking about cosmetics, talking about plastics. For example, today, I don't think that I heard from the presentation textiles. Are they other, let's say, specific product areas that you think should be having, let's say, a dedicated policy framework or policy incentives? Are they other sectors that we haven't mentioned today that you feel are relevant? If anyone has insights or ideas on that, don't hesitate to take the floor.
Yeah, maybe I can answer this one. Maybe Georgian can make another point of view. But in the case of plastics and textiles, in some kind of plastics are closely related to textiles. So, for example, when we are talking about polyester, don't think just about the bottles, but you can also turn it into textiles. So at this point, I think there will be a direct relationship between plastics and textiles. Maybe with other kind of textiles, not. And I don't know if there are technologies who are able to turn carbon dioxide into other kind of fossil-based textiles. But at least in the case of PET, I think it's possible.
Thanks a lot, Nicolas. And then maybe Gertjan, yes, you can complete.
Yeah, it was exactly the same point I wanted to make. Indeed, so we are targeting textiles, also with the polymers that we make, because that's a 100 million ton market, which is very closely related to the same plastics that we use for other applications. And so that, yeah, from a volume point of view, that's a very interesting area now as well. But it's even more cost competitive and difficult than in packaging and other applications.
Because maybe for some maybe to make sure that everyone has this in mind, so the European Commission is also working, let's say, on product category, let's say, policy. So for example, under the eco design requirements directive, you have a regulation, you have a number of requirements, for example, for producing more sustainably a number of products. And from our perspective, what would help is that policymakers, EU institutions, take into consideration CCU as one of the factors that could be used to, let's say, to promote more sustainable products, for example, in packaging and in textiles. And if we take the example of plastics, in the last few years, at least at EU level, the focus has been a lot on recycling, on reuse, on use of recycled content, which is fair enough because it's one of the very important part of the debate. But it's true that the other elements, for example, on where the carbon is coming from, where the virgin carbon is coming from, has been a bit like under the radar. And one of our strong recommendations towards the EU institution would be to say that we need to have more of those quotas or elements, for example, on alternative carbon feedstock that could be in the legislation and that for now are not there, essentially. I mean, Algret was mentioning the sustainable carbon cycles communication, which was published already 2 years and a half ago, and which was saying we need at EU level for 20% of the carbon used in chemicals and plastics to be non-fossil. So when they say non-fossil, they mean biomass recycling or CCU by 2030, which is a very good objective. But from our perspective, that has yet to be translated into legal provisions. So for now, we have this kind of, let's say, aspirational target where the European Commission is saying it would be great if, but we don't have like the let's say the proper translation, or at least not yet, into binding legislation. So that's amongst the very, very important part that we need to convey to the European Commission. I'm checking at the same time. We have a few minutes left for the Q&A. If you have other questions, again, like, feel free to add them to the chat. There's a question specifically on COSMOS. Maybe we can take that one. So the question goes like this: the COSMOS project shows that many chemical building blocks can be produced more sustainably, minus 60% CO2 emissions, and cost efficiently, minus 40% cost. What is the recommendation from the project on how EU policies can valorize such processes and technology? Okay, so that's quite a broad question, but maybe that can help the colleagues from COSMOS, like, saying a bit more about, let's say, their overall results and recommendations for EU policymakers.
It's a good question and a broad, really broad question. Probably linking with the question that you are talking about before. I think that a good idea, or I don't know if it's possible or feasible, will be to try to, when you talk about feedstock, non-fossil feedstocks, trying to replace these fossil fuel feedstocks. I don't know if it's possible to specify a specific percentage of feedstock, of material coming from, for example, carbon dioxide, and other materials coming from biomass. So this is could be an idea to try to make things easier for these technologies to be adaptive to the amounts of carbon dioxide that must be turned into products.
Yeah, so that's typically the type of debate that you had in the packaging and packaging waste regulation. So whether you should integrate, how to integrate like the different ways to make your products more sustainable, and should it be on the same level? From a political perspective, it was a very, very difficult, let's say, debate that took place at EU level. But I think any recommendation in that side that we can share with policymakers will help, in particular, as we see the new political cycle after the elections starting. So all those elements from the different projects will be very, very helpful.
What I mean is,
yes, go ahead.
if you said, for example, a 15% of material who must come from carbon dioxide, industries and all the industries in the sector will have to think about this percentage that they must fit, so that it's I think it's can be an input to promote the development of these technologies.
Yeah, thanks a lot, Nicholas. We have a few minutes left, but one that I also think, okay, even if the question is very broad as it's been put in the chat, but I think it's still a relevant one. How can we enhance collaboration between stakeholders on CCU chemicals? I mean, one of the elements is this transition pathway that DG Grow was presenting. I think more broadly, there's also the element around how to engage, for example, with civil society, how to get, for example, non-governmental organization on board. I mean, at least from our experience as CO2 Value Europe, for example, in the energy side, in the side of moving away from fossil fuels, you hear plenty of discussions, you hear plenty of debates on how we can move away from fossil fuels, what is the way forward, what are the different solutions to put in place, and so on. I have to say, at least from my experience, that it's a bit less the case in the chemical space, where you have like less of those kind of debates and exchanges between industries and NGOs and academics and so on. I don't know if there's elements that any of the speakers want to share on how to better collaborate, or how to create that dialogue and discussion between companies and civil society and policymakers. Nope, maybe too broad of a question. I also see that we have a hand up from the participants, but I'm not sure if we can give them the floor directly. Maybe I can suggest to this person to...
If we want, we can. Otherwise, we can invite them, to put the question in the chat, as you prefer.
I don't know. We have a couple of minutes left, so maybe we can we can give the floor to that person and address it as the last question for the Q&A. That person, if you're able, Lara, to
yeah, they already they should be able to talk, so okay. The microphone will be active.
Good morning. Yes, thank you for allowing me. My name is Silvia Mattagliati. I'm basically your policy officer in DG RTD, and I'm the responsible for drafting the calls for topics under Horizon Europe and the Circular Bio-Based Europe joint undertaking concerning the CCU of biogenic gaseous carbon capture and use, basically from the bio-based industrial installations. So I know it's not the core of the discussion of today, but I want to say that I was very pleased to listen to all the very good, I would say excellent presentations and excellent discussions. So thank you very much for this opportunity. And I would have maybe loved to follow all the projects more closely. But I would like just to raise attention to you, but maybe you are absolutely aware about the fact that in the annual work program recently published of the Circular Bio-Based Europe joint undertaking, there is in fact another innovation action that will be funded with a grant of 15 million And I really hope that for 2 projects, and I really hope that all the experts that I listened to today are indeed aware of that and will be ready to participate and submit proposals. And then I would like maybe one day to have some discussion on how to further, say, support research and innovation in that specific field, because in fact we are always under discussion on how to shape the future, scenario under Horizon Europe and the joint undertaking as well in that respect. So, and how to progress in a way that these technologies, the most promising technologies, and I understand now that there are some say promising technologies, reducing the energy consumption and lowering the environmental impacts, how we can support them and their uptake to the market level, basically. As the TRL of this innovation action foreseen for this year is actually the engine TRL is 6.7, but of course we would like also to grow and increase our ambition. So just to say to everybody hello, and yes, if you have some comments or suggestions for the future R&I programming. Thank you.
Thanks a lot, and thanks for taking the floor. And great to hear that that DGRTD is following this work with enthusiasm. And thanks for your kind words as well. But for sure, we'll I think many of the experts that you heard today will be happy to follow up and discuss on some of the other funding opportunities for those projects. So thanks a lot for this. Okay, I think I'm done with the time that I was given. So I'll give back the floor to Francesco, and I think we'll go for the conclusions of this webinar. Thanks a lot, everyone. Thanks a lot for your very good questions and for the interaction. Thanks.
Well, thank you, Tudi. I think you did a wonderful job. Thank you very much to you for managing those questions very nicely. Thank you also from my side to Silvia Maltagliati. It was very nice that you came in at the end there and brought that together for us nicely. And now a very, very difficult job. I'm going to ask Anastasio Perimenis to provide us with his summary of the learnings and conclusions drawn here today. And obviously it's difficult to put it all together, but let's see what we've managed to put together today. Thank you. Anastasio.
Yes, thanks, Francesco. So we heard a lot today. Very, very interesting discussions, very interesting questions and responses. So I'll try to resume the main things, at least that I could take out from this discussion. First of all, I think it is reasonable to recognize now that the chemical sector has received or is starting to receive the attention that it merits in terms of defossilizing it. We've heard from Algrade and the Commission about the work being done on the transition pathway, and I think a lot of the things that have been presented there are resonating very well to the needs of the chemical sector. Mostly I have noted down the task forces on the potential of creating market pull mechanisms for uptake of CCU solutions, or of uptake also of solutions that are starting with an alternative carbon feedstock. So also work on the Sustainable by Design directive from the entire life cycle, so that we can produce more sustainable chemicals that eventually are not produced from fossil resources. So there is an effort to translate the requirements of the industrial carbon management strategy through also the work being done on the chemical transition pathway to actionable and tangible targets, be it downstream pull, market pull measures, or upstream measures like suggesting quotas for an alternative carbon feedstock in our final products. There is work being done on the chemical transition pathway, and there is the interest of the stakeholders to collaborate there. So that's one important takeaway message. Another one is that by nature, our three projects are focusing on biogenic CO2. This doesn't mean that these technologies are not adapted also to other sources of CO2. But given the focus of the topic, we are focusing on biogenic CO2. And the question that is open in the air, let's say, is whether this will lead at some point to a competition for this biogenic CO2, also from a carbon dioxide removal point of view, from a CCU point of view also. So biogenic CO2 will become a commodity in the future. So we'll have to see how the market will be able to incorporate this. We have noted down the challenge of increasing scales and decreasing costs. It will depend on the type of product that we will create with CO2. It will also depend on the competition between using the CO2 and either using it or storing it, but continuing with the business as usual from a fossil-based chemical sector. So this was an important question to consider also for the future. How will the costs of the value chain evolve depending on whether we will use these resources to produce marketable products or whether we will store the CO2 and continue the business as usual fossil-based chemical production systems. There is a focus we've heard on the polymer side and subsequently also on the textile side. And this will also be defined by which products at the end will gain more market share in the future. We have heard Sylvia saying that there is a need and an interest on the DGRTD side to continue the funding from those type of projects along the TRL scale, so that there is a continuity for technologies like the ones we have in COSMOS, CATCO2NVERS, and VIVALDI to find their way up to industrially relevant scales. So indeed, please apply to those calls that are upcoming now, also from CBE and Horizon Europe overall. And I think basically that's it on my side. I hope I have been able to summarize the main things that we have heard. And for the continuation, for the follow-up, it is important for us to analyze the content now of this workshop and take it and bring it to the attention of the policymakers from different DGs. As Sylvia said, it is important for actors like our projects to be able to communicate these results and these outcomes so that funding is continuing, so new topics are created, but also on the more political side, that policymakers like Algrate that was with us today, or other policymakers, the ones that are behind the industrial carbon management or the ones that are behind the net zero industry action, that they are aware of the results that are coming in from EU projects. And so we will gather the content and we will analyze it and we will bring it to them so that they are aware of the challenges that our sector faces. That's it on our side, Francesco. Thank you.
Thank you very much, Anastasios Perines, there from CO2 Value Europe. Very good job in bringing that all together. Now there's nothing left but to say thank you to everybody who has attended and had remained until the end. A very big thank you to Lara Totolo, Iris de Cesare, the backbone of the organization team who made this possible, brought it together. Thank you very much to you. Thank you to Rob Slade from our team who's been working in the background together with Anastasio, putting on mirror boards. And lastly, and most grateful for all the panelists for your attendance and your time, and really your concentration and effort. So a big thank you to everybody. Please take a look. We have the projects are all online, and we would love for you to click in there and follow and join our social media campaigns so that you can remain up to date with developments. From our side and from the organization teams and the projects, thank you very much, and goodbye.